I have a whole set of kind of philosophies around the idea that you start programming in the sense that you're trying to get something to work. You always are in a programming mode at the beginning. Let me just find some code. I don't care what it looks like. Let me get something to work. And then for me, you have to move into an engineering frame of mind, even if it's prototype work. Some of the most dangerous programming I see is the code that somebody does and hands it off to somebody else, thinking that they're going to now do the engineering piece, and they don't. And that code ends up in production. And so there's a bunch of kind of philosophies around moving from programming to engineering, right? So look, Wes Dyer said this: make it correct, make it clear, make it concise, make it fast, right? But those are 4 steps. To me, those are 4 different refactorings that you have to do to a piece of code.
In that order.
In Wes's world, it's in that order. And I agree with Wes, right? But there's other refactorings you should be doing for code. Make it precise. He might be saying make it concise, right? And I think he means precision there. Can we make the API cleaner, right? Can we make the AI more precise in terms of what we need? And then to me, there's a piece that is lost too. There's a refactoring piece about making something testable. And I think sometimes people start with the idea that this is going to be testable. No, what does it mean for something? It's a refactoring piece. I've worked on a function for 3 hours with somebody where we made it correct, we made it clear, we made it concise. And then they thought, wow, this is great. I said, yeah, this is great, but it's not testable yet. We need to refactor this to make this testable. We need to think about how we can do that without having to add an interface, without having to add an abstraction, without having to do some of the things that we kind of, right? So a design philosophy for me is this: you write things in the concrete first, then you ask, does that need to be polymorphic? Does that require an abstraction layer? In other words, can that function continue to ask for data based on what it is? Is there a reason why it needs to ask for data based on what it can do? And I think too many of us default to the idea that everything should be asking based on what it can do. And I say, no, that's an engineering cost. First of all, it's an allocation out of the box. And second, it's an abstraction that doesn't necessarily make our lives better. So it's a stage, right? And sometimes the answer is yes, this is a situation where we should be decoupling the code. And there's times where no, we only have one implementation of this. So let's not do something for the sake of doing it. That's another design philosophy.